the Earth is a remarkable piece of real estate, and a busy one at that, from ever-changing weather patterns to the hustle and bustle of city streets. Our planet is in a constant state of motion. However, if we take a look just below the surface, we find that things are always moving. Our feet as well. It's called plate tectonics, and it's how the continents were formed and reformed. But before we get to that, let's dive underground. To learn what our planet looks like from the inside out, our planet is made up of layers, and there are two types of layers we need to learn about in order to understand plate tectonics: the compositional or chemical layers and the mechanical layers. We could spend an entire session on what makes both of these types of layers unique, but for this lesson we're simply going to provide an overview. There are three primary compositional layers to the Earth's surface, and these are probably the ones you're familiar with: the crust, the mantle, and the core. It's important to understand that the compositional layers refer to the materials or elements the Earth is made of. However, if we take a look at how the inside of the Earth behaves, we can divide them even further into mechanical layers. Starting from the outside, working in the lithosphere, is the outermost layer, which contains the entire crust. In the topmost layer of the mantle, the asthenosphere contains the same materials as the top layers of the mantle, but the pressure in the heat are increased. It's not exactly a liquid, but does move like heated rocks, so you could say it's somewhat fluid. The mesosphere is next. At this level, the pressure is really starting to build, which restricts the molecules' ability to move, thus molecules' ability to make it very rigid. Past the mesosphere is the liquid outer core. Extremely high temperatures melt the metals contained in this layer into liquid form. Think flowing rivers of lava, and you all have a pretty good idea of what the outer core is like. And finally we reach the solid inner core. Just like the liquid outer core, the inner core has extremely high temperature and is composed of mostly metals, which might lead you to ask, why isn't it liquid as well? The answer is pressure. There is so much pressure at this depth that even though the temperatures are beyond the melting points of the metals contained in the inner core, the high pressure essentially squishes everything down into a solid.